All right, so topic 9 review. We'll kind of start each problem and let you guys finish through it. So it tells us in this scenario that shape A, B, C, D, E is similar to shape G, H, J, D, F. It just wants you to complete the statement. So what am I looking for here? Not really what is the answer, but what kind of geometric figure, what should the answer look like? Should it be an angle or should it be a line segment? This should be an angle, right? It's an angle answer. You don't really need the shape. All you need to know is where is H in line for the similarity statement, and what is the same letter in line for the other similarity statement. So it's kind of matching up orders there. For part B, you have GH, which is this piece right here, which is proportional to DJ. So that's like roof over basement is equal to AB, which is the roof of the big house, over the basement of the big house. So it's kind of your job to figure out what is the basement of the big house. Or you can look at it is GH over DJ, and then AB over the third and fourth letters. Right? So you kind of pick out what those are. That will happen quite a bit on your test, so just make sure you know how to read a similarity statement. All right, number 2, this goes back directly to what we did yesterday. This is that bisector theorem. In this scenario, you should be able to see your proportions. We did this yesterday. So your proportions look like this. This is one proportion, and this is the other proportion. Okay, it's just the weather. We'll be okay. So it does not matter how you set your proportions up, as long as it's consistent. So does anybody have a particular flavor they like to do? You like to do X on top? So that's fine with me. You do X over 6.9, and because you have X on top, your proportion went this way, then 12.6 must be on top, and your proportion has to go that way, which is 12.6 over 8.5. So that's what like doing 70% of the problem looks like. I'm asking you guys to cross multiply and solve by yourself to get the answer. All right. Now I don't really care about what theorem it is, or sorry, what the answer is. There's no numerical answer here. It's a shortcut answer. So you have 3 options. Option 1 is angle shortcut. Option 2 is the side angle side shortcut, and option 3 is the side shortcut. So, any ideas? Let's go ahead and do this whole problem. What do you think? You see how we have one angle? We have one angle right here, which is congruent to this angle right here. If you see it, there is this angle and this angle that are congruent. So it's the angle shortcut. You don't have to mess with any proportions there. Perfect. Right? That's the math monster coming to get you. Just make sure you write the answer of what it is. Number 4, again, which theorem or which shortcut proves that these two triangles are congruent? So again, same 3 options. The angle shortcut, the side angle side shortcut, or the side shortcut. So is there 3 sides to both triangles? There's a numerical value with each side of each triangle. So we can't use this one. Right? We're missing a number here. We're missing a number here and here. Does each triangle have 2 sides described? Right? This triangle has 2 sides described. This triangle just has 1 side described. So can we use the side angle side shortcut? No. So we can kind of justify without knowing anything else that it is angle angle, but it's really good to know which 2 angles are congruent. Which one? This one right here and this one right here are congruent because they're corresponding angles. And then there's another set here and here that are corresponding angles. Right? Are these polygons similar? If so, write a similarity statement. So, and give the scale factor. Ooh, man. So this was day 1, 9.1. Are these 2 shapes similar? So, does it have a pair of congruent angles? Yeah. So if we want to see if they're similar, we have to check and see that each side is proportional. So we have a number here, and what does it correspond to on the other one? So this 4 is the small number, and 1.6 is the small number. So we have, be careful here. If we want to do double math, which one's our new shape? The one on the right. So if we want to automatically kind of describe our scale factor, we can do the new shape over the old shape. That would be an example of what your scale factor is, 1.6 over 4. Now we're trying to check if this number proportion is the same as the other side. So we did 1.6 over 4. What's the other side of that polygon? 4.8 over 9.6. Now, do we need to write all 4 proportions? Not really, because as soon as I choose 4 over 1.6, it's the exact same thing, or 1.6 over 4. And as soon as I write 4.8 over 9.6, it's the exact same thing as that one. So it's just your job to cross multiply and see if their cross products are the same. If they are, you can write a similarity statement. And make sure your similarity statement is like 1, 2, 3, 4 letters are similar to 1, 2, 3, 4 letters. If it's true, you have to figure that out. It worked? Someone said that it is similar. They did the cross product, so just make sure you check it for yourself and write the correct statement. Are these 2 triangles similar? Guys, this is one of the ones that y'all goofed on a lot. You see how there's 2 angles in this triangle? Just go ahead and do a little bit of math and find the third one, please. So if you add these 2 numbers together, you get 113. So 53 plus 60 equals 113. Now if I do 180 and I subtract 113 from it, you get 67. So I know for a fact that this angle is 67. Do I care about this one? Not really, because you should see something right now. By doing one little piece of math, you should see something, and that should tell you something, and that's what you write for the answer to this question. All right, just a little bit of math there. Are these polygons similar? Oh, I'm sorry. The polygons are similar, but they're not drawn to scale. So I'm asking you guys to find x. So help me set up a proportion, and then I'll let you solve it when we're done. What are you trying to solve for? X. So you want that to be somewhere in your proportion. X minus 3 corresponds to 2.5. So these work. Does it matter which other sides you use? It doesn't. You can pick whatever makes you happy. What would be the smart decision? 8 and 2 because they're smaller numbers. So you can choose this one over this one, 8 and 2. Then you would cross multiply and solve for x. So I'll leave that, the rest of the problem for you there. These polygons are similar, but they're not necessarily drawn to scale. What is x? I don't know how much nicer that can be, right? There is only 2 numbers on 2 shapes, and I'm asking you to set up your proportion. Help me do it, and then we'll move on. X over 3, so we're going to go this way this time. X over 3. So stay consistent. Now we have to do 31 over 12. It's open. It's not open. It is open. Hello. Cool. So then you would solve that by yourself. Does that seem impossible? Guys, that's something that you're going to have to do on the test like time and time and time again. Oh. Are these triangles similar? If they are, tell me what you used. Okay. Now this question can be uber difficult because there's like 4 different answers. JJ says side splitter. And I would normally agree with you, but you're missing one key piece of information. Are KJ and NM parallel? Where does it say that? So if there was parallel lines here, you could use the side splitter theorem. And you would say 9 over 3, 15 over 5. You guys can see 3 times 3 is 9, 5 times 3 is 15. They would be proportional. But we can't use that because I don't know if those lines are parallel. So now you're left with only these 3 options. Because the lines are not marked as parallel, we use that corresponding angles thing. Corresponding angles only happens when lines are parallel. Can you see this reflexive O right here, where O is part of the big triangle and O is part of the small triangle? So in this scenario, I'm asking you guys to use the side angle side shortcut and set up a proportion like left side over left side is equal to right side over right side. And you have to add the whole length. So the top is 9, the whole thing is 12. This part is 15, the whole part is 20. That gives you your proportion. If you cross multiply and they are proportional, then the triangles are similar by the side angle side shortcut. So I'll let you finish that one up. State whether these triangles are similar. If they are, write a similarity statement. What does that look like? Does that look like side, side, side? Does that look like angle, angle? Does it look like side, angle, side? So all we got to do is set up our proportions. 8 over 16 and 32 over 64 to check to see if they are proportional. If the answer is yes, the triangles are similar, and I'm asking you to write a similarity statement. This triangle is similar to this triangle. If they are similar, if the proportions check out. Huh? Did I miss the triangle somewhere? Number 11. For the following statement, state whether the triangles are similar. Where's the other triangle? Is it? I think it's a mistake. So guess what? Yay. Skip it. Okay, this goes back to yesterday. This is the corollary of the slide splitter. Do you see your proportions? You seen them right here? They even like drew the line between the proportions for you. There it is. Those are your proportions. You're trying to set up and solve 24 over x equals 36 over 12. Solve for x. Oh, glorious, glorious, glorious. Probably the toughest question. Why? So what are we going to do when we see right triangles in right triangles? Draw 3 triangles. So here we go. Why is this different than every other question we've done about right triangles? There's no numbers. So what do? Look at my first little baby right triangle right here. If you can't describe that by a length, you can describe that by its vertices, or where each one is. So which one's next to the right angle? What letter? U. So this makes this letter, and this makes this letter. So we have triangle UVW. Right? Not terrible. Then we have this triangle right here. So what goes right here on the right angle? U. What goes over here on the other side of the short leg? And what goes up here at the vertex? So let me draw a different color here. Okay, here's the right angle. So if you look at it, U is next to the right angle, and then the short side is UW, so I need the short side to be UW. The hypotenuse is TW, right? That's across from the right angle, so the hypotenuse is TW. And now I got this big old monster triangle that looks like this. And the right angle is right here. So what letter is next to the right angle? W. Okay, go across the short side. What is the other letter on the short side? And then what is the letter on the top of the hypotenuse? T. So just by setting those up, you should be able to set up proportions, right? Because all of our triangles are drawn the same way, we can say that VU is proportional to WU, right? That's the bottom over the bottom. Then we could say that UW is proportional to TU. That's what the question is asking for, right? To set up proportions that you could solve for. Remember, you can always check, does this proportion and this part of the proportion, do they match? UW and UW. So you can see you set it up correctly because the diagonal pieces are correct. So if you probably did one more proportion just for practice by yourself, that would be good, a good spot to be in. For your test, they will be like numbers. Just solve for x. The geometric mean. What? 2 steps. Step number 1. That's what you gotta do. Step 1, multiply them. Step 2, take the square root. I'm gonna go through this entire problem with you because, did you already do it? Okay, on the test it's gonna be a little weird. So 4 times 5 equals 20. Step 2, take the square root of 20. Give me as many, as clean or dirty as it is, like 5 decimal places.
4.47214.
Your test is going to ask for 2 decimal places. And it's going to ask you to round to the nearest 2 decimal places. So what would your answer be that you would bubble in on your test? So this is all you would bubble in is 4.47. So just make sure you know that you're asking for 2 decimal places. It makes sense? If it was like 4.479, you would round up to 4.48. The way it's set up, I think whatever you see, the first 3 numbers, like 4.29, that's what it's going to be. Because the third decimal is going to be like a 0 or something. Hey, same thing. I think you can handle it. Step 1, multiply. Step 2, take the square root. Are these triangles similar? Ugh. Who's got a calculator handy? Who can do 180 minus 30.4 and 84.6? Or 180 minus 34.4 minus 84.6? Right on the nose. 55? 65? So calculator says 65. If you add these 2 numbers together, you get 115. So 180 minus 115 is 65. This angle is 65. Do I need to do any more math? Are these 2 triangles similar? These match. These do not. So are they similar? No. I think we had a lot of practice with this. These triangles may or may not be similar. Tell me which shortcut proves that. Make sure you read this statement right here. What does it say about PQ and BC? They are parallel. Now that these lines are parallel, you can use the side splitter theorem. You can say that 7 over 14 is equal to x over 18. And you would just finish cross multiplying and solving there. Should get a nice round whole number. Ooh. Alright, this one kind of sucks because you have to add all the information yourself. It says that ray LO bisects angle NLM, so it cuts this angle into 2 equal pieces. LM is 18. NO is 4. And LN is 10. So once you add all information, you get the bisector theorem, and you can set up your proportion 10 over 4 or 4 over 10, doesn't matter. 10 over 4 equals, because I did 10 over 4, it has to be 18 over x. And you can cross multiply and solve there. All right, last one. Ooh, are these, what are the values of A and B? First question. Are these both right triangles? Is this right triangles inside of right triangles? No, it's not. So you want to say that you're going to start drawing 3 right triangles, right? But there is no right angle right here. It doesn't say that's a right angle. You do know that this is 90 degrees. So if this piece is 90 degrees, how big is this piece? So you have just 2 right triangles. You have this one right here. There's a right angle, and there's a congruent angle marked. So what is between the right angle and the angle marked congruent? A 20. Down here on the other side is an A, and the hypotenuse across from the right angle is B. Okay, we have another right triangle right here. The congruent mark, we can add a congruent mark. So between the 90 degree angle and the congruent mark is a 21. Between the right angle and the angle that's not marked is a 20. And the hypotenuse is a 29. So you have 2 similar triangles, and then you can set up a proportion to solve for A and B. You can do B over 29 is equal to 20 over 21. So that will solve for B. Because I already have a proportion that works, 20 over 21, you can use 20 over 21 and A over 20 for your last one. So you can solve this set of proportions first, then you can solve that set of proportions second. You can cross multiply with the same proportion in the middle. Okay, so that leaves you about 20 minutes to go back and calculate and kind of finish up each problem. If it's completely done, you'll get a couple bonus points tomorrow on the test.